The National Electrical Code, or NEC, outlines the requirements for grounding electrical equipment to ensure safety and prevent electrical shock hazards. Grounding involves creating a low impedance path for fault current to return to the source, allowing overcurrent protection devices like circuit breakers or fuses to quickly clear the fault. Section 404.9b states that all enclosures of electrical equipment, including junction boxes, lighting fixtures, and other devices, must be grounded. Section 250.148a specifies that grounding screws or other approved means should be used to connect equipment to the grounding conductor. Now, let's discuss the specific requirements for grounding screws in junction boxes. For non-metallic junction boxes, Section 314.28 requires that a separate grounding screw be provided. This grounding screw serves as the dedicated point for connecting the equipment grounding conductor within the box. This is because non-metallic boxes do not inherently provide a conductive path for grounding. For metallic junction boxes, Section 314.28b states that the box itself may be used as the grounding means if it is effectively bonded to the grounding conductor. This means that the metallic box must be in direct contact with the grounding conductor, providing a reliable path for fault current. This can be achieved using grounding screws, grounding clips, or other approved methods. Moving on to lighting fixtures, Section 410.23 allows the use of rigid or threaded metal or non-metallic conduit as the grounding means for lighting fixtures, provided it is securely fastened to the fixture and to the grounding conductor at both ends. This ensures a continuous grounding path from the fixture back to the electrical panel. Section 410.24 addresses lighting fixtures mounted on boxes. It states that the fixture mounting screw or screws may be used as the grounding means if they are securely fastened to the box and to the grounding conductor. This method relies on the secure connection between the fixture, the box, and the grounding conductor to provide a reliable grounding path. For hanging or suspended lighting fixtures, Section 410.25 permits the use of a separate grounding conductor to connect the fixture to the grounding conductor. This is common in installations where the fixture is suspended from the ceiling using chains or other non-conductive materials. In such cases, a dedicated grounding wire must be run from the fixture to the grounding system. It is important to note some additional requirements regarding grounding screws. Firstly, grounding screws must be of sufficient size to accommodate the grounding conductor being used. This ensures that the screw can effectively clamp and secure the conductor, providing a good electrical connection. Secondly, grounding screws must be securely tightened to ensure good electrical contact. A loose grounding screw can create a high resistance connection, which can impede the flow of fault current and compromise the effectiveness of the grounding system. Thirdly, grounding screws must not be painted or otherwise coated in a manner that impairs their conductivity. Paint or other coatings can create an insulating layer between the screw and the grounding conductor, hindering the flow of current. It is crucial to ensure that the grounding screws are clean and free of any coatings that could impede their conductivity. In summary, the NEC provides specific requirements for grounding screws in junction boxes and lighting fixtures to ensure electrical safety. For non-metallic junction boxes, a separate grounding screw must be provided. For metallic junction boxes, the box itself may be used as the grounding means if it is effectively bonded to the grounding conductor. For lighting fixtures, various methods are permitted, including the use of conduit, fixture mounting screws, and separate grounding conductors. Grounding screws must be of sufficient size, securely tightened, and free of any coatings that could impair their conductivity. By adhering to these code requirements, electricians and installers can ensure that electrical equipment is properly grounded, reducing the risk of electrical shock and fire hazards. Furthermore, it's vital to understand the purpose of grounding. Grounding is not just about protecting equipment, it's primarily about protecting people. In the event of a fault, where a live wire comes into contact with a metal enclosure, the grounding system provides a low impedance path for the fault current. This high current causes the overcurrent protection device, such as a circuit breaker, to trip, quickly disconnecting the power and preventing a dangerous shock. Without proper grounding, the metal enclosure could become energized, posing a significant risk of electrocution to anyone who comes into contact with it. Therefore, the correct installation and maintenance of grounding systems are paramount for electrical safety. When selecting grounding screws, it's essential to choose those that are specifically listed and labeled for grounding purposes. These screws are typically made of corrosion-resistant materials and have a design that ensures a secure and reliable connection. Never use regular screws for grounding, as they may not provide adequate conductivity or mechanical strength. Also, it's important to use the correct size grounding conductor for the application. The NEC specifies the minimum size of grounding conductors based on the size of the circuit conductors. Using a grounding conductor that is too small can limit the flow of fault current and compromise the effectiveness of the grounding system. When connecting grounding conductors to grounding screws, ensure that the conductors are properly stripped and cleaned. Use appropriate tools to tighten the screws to the manufacturer's recommended torque. Over-tightening can damage the screw or conductor, while under-tightening can result in a loose connection. After making the connection, inspect it carefully to ensure that the conductor is securely clamped and that there are no loose strands. In addition to grounding screws, other grounding methods may be used in conjunction with or as an alternative to grounding screws. These methods include grounding clips, grounding lugs, and bonding jumpers. Grounding clips are typically used to connect grounding conductors to metal enclosures. They provide a quick and easy way to establish a grounding connection without the need for drilling and tapping. Grounding lugs are used to terminate grounding conductors at grounding buses or equipment grounding terminals. They provide a secure and reliable connection that can withstand high fault currents. Bonding jumpers are used to connect metal parts of electrical equipment together to create a continuous grounding path. They are commonly used to bond metal conduit, enclosures, and other metal components. Regardless of the grounding method used, it's essential to ensure that all connections are tight, clean, and corrosion resistant. Regular inspections of grounding systems are crucial to identify and correct any problems before they can compromise electrical safety. Look for signs of corrosion, loose connections, or damaged grounding conductors. If any issues are found, address them promptly to maintain the integrity of the grounding system. Remember that grounding is an integral part of electrical safety. Proper grounding protects people from electrical shock, prevents equipment damage, and reduces the risk of fire. By understanding and adhering to the NEC requirements for grounding screws and other grounding methods, electricians and installers can ensure that electrical systems are safe and reliable. Furthermore, it's important to understand the concept of bonding, which is closely related to grounding. Bonding is the process of connecting together all metal parts of an electrical system to create a continuous electrical path. This includes metal conduit, enclosures, equipment frames, and other metal components. The purpose of bonding is to ensure that all metal parts are at the same electrical potential. This minimizes the risk of electrical shock if a fault occurs. When a fault occurs, the fault current will flow through the bonding system, tripping the overcurrent protection device and disconnecting the power. If the bonding system is not properly installed, the fault current may take an unintended path, such as through a person's body, resulting in an electrical shock. Therefore, proper bonding is essential for electrical safety. The NEC provides specific requirements for bonding electrical systems. These requirements include the use of bonding jumpers to connect metal parts together, the proper sizing of bonding conductors, and the proper installation of bonding connections. It's important to follow these requirements carefully to ensure that the bonding system is effective. In addition to the general requirements for grounding and bonding, there are also specific requirements for certain types of equipment. For example, swimming pools and spas have specific grounding and bonding requirements to protect against electrical shock hazards. These requirements include the use of equipotential bonding to connect all metal parts of the pool or spa together, as well as the installation of ground fault circuit interrupters, or GFCIs, to protect against electrical leakage. Similarly, agricultural buildings, such as barns and stables, have specific grounding and bonding requirements to address the unique electrical hazards present in these environments. These hazards include the presence of moisture, corrosive substances, and livestock, which can increase the risk of electrical shock. The NEC provides detailed guidance on how to ground and bond electrical systems in agricultural buildings to ensure the safety of people and animals. Finally, it's important to remember that electrical codes and standards are constantly evolving. The NEC is updated every 3 years to reflect new technologies, best practices, and safety concerns. It's essential to stay up to date on the latest code requirements to ensure that electrical systems are installed and maintained in accordance with the current standards. Continuing education and training are crucial for electricians and installers to stay informed about the latest changes to the NEC and other relevant codes and standards. By staying informed and following the code requirements, electrical professionals can help to ensure the safety of people and property. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer before undertaking any electrical work. They can assess the specific requirements of your situation and provide tailored recommendations to ensure that your electrical system is safe and compliant with the applicable codes and standards. Furthermore, consider the environmental factors that can affect grounding systems, especially in Florida. The high humidity, salt air, and frequent thunderstorms can accelerate corrosion and degradation of grounding components. Therefore, it's crucial to use corrosion-resistant materials and construction techniques. Stainless steel, copper, and coated steel are commonly used for grounding electrodes, conductors, and connectors in corrosive environments. Regular inspections and maintenance are essential to identify and address any signs of corrosion or damage. Replace any corroded or damaged components promptly to maintain the integrity of the grounding system. In areas with sandy soil, the soil resistivity may be high, which can reduce the effectiveness of grounding electrodes. In such cases, it may be necessary to install multiple grounding electrodes or use chemical ground rods to improve the grounding system's performance. Consult with a qualified electrician or electrical engineer to determine the best grounding solution for your specific site conditions. Lightning protection is another important consideration in Florida, given the frequent thunderstorms. While grounding is an essential part of a lightning protection system, it's not a substitute for a complete lightning protection system. A lightning protection system typically includes air terminals, down conductors, and grounding electrodes, all designed to safely conduct lightning current to ground. If you're concerned about lightning strikes, consider installing a complete lightning protection system to protect your property and equipment. When working with electrical systems, always follow safe work practices. Wear appropriate personal protective equipment such as insulated gloves and safety glasses. De-energize circuits before working on them whenever possible. Use a voltage tester to verify that circuits are de-energized before touching any wires or components. If you must work on live circuits, use extreme caution and follow all applicable safety procedures. Never work alone, and always have someone nearby who can assist you in case of an emergency. Finally, remember that electrical work can be dangerous. If you're not comfortable working with electricity, it's best to hire a qualified electrician. A qualified electrician has the training, experience, and tools to safely and effectively install and maintain electrical systems. They can also ensure that your electrical system is compliant with all applicable codes and standards.